Hi all, welcome to the first lesson for Secondary 3. First, I want to talk about my notes looking just a tad different than yours. I did it to make the ease of the recording go a little faster. So if you need to pause or rewind the video to get everything, please do so. That being said, we're going to go ahead and start. Our first unit is functions and their inverses, and our first lesson is functions, domain, range, and evaluate. Our essential question for the day is how are the domain and range of a function found, and how are functions evaluated? So we're going to go ahead and start with some vocabulary. Our first vocabulary word is relation, and it's the set of input and output values, usually represented in ordered pairs. Okay? And then I have a little picture over here that helps. I have input. It shows the input and the output for us. Okay. Our second word is domain, and that is the set of all input values of a function. Basically, that's the x values, okay? And if I was to find the domain of our little problem I have over here, of the picture that I've given us, my domain is my input value. So I'm going to look at my input. So it's these values, and I want to make sure when I put it into my set that I write them in order from least to greatest. So that means my domain is going to be 1, 3, 5, and the set closed. So there's my domain. My range is a set of all output values of a function. So basically that is my y values. So I'm going to do my range. I'm going to do the same thing. So here's my range. Again, I want to make sure that I'm writing it from least to greatest. So that means my range would be 2, 6, and 10. Okay, so there's my domain and my range from my problem that I have. And our last vocabulary word is function. And a function is a special relationship where each input has a single output. So basically it's saying every x has only one y, and it is often written as f of x, where x is my input value. Okay? Awesome. Good job, you guys. So now we're going to move on to how we recognize these in different forms. So how do I recognize a function, no matter what form it is in? So out of these problems that are coming up, we're only going to do a few of them because when we meet on Zoom, you're going to do some of them in breakout sections and talk to each other and help each other with it, coming up with the answers. Okay, so here we go. We're going to do this table right here on this one. So it says determine if the relation given in the table is a function, and if it is, find the domain and range. So I want to determine if it's a function, and then I want to find, if it is, I want to find the range and domain and range. Okay, so how do I determine if the relation is a function? Well, I'm going to look at my x's, and I really want, if it is a function, I really want to make sure that there's only one x, one of the same x. So I don't want double x's. So like if I have a -3 here, there should not be another -3. And there shouldn't be another -2, and there shouldn't be another -1, there shouldn't be another 0, there shouldn't be another 1, and there shouldn't be another 2. So they're all distinct individual x's, which we have here. So that's good. So that means this is a function. Awesome. So that's a function. Now it says state the domain and range. So I want to do my domain. Again, it needs to be in order from least to greatest. And luckily in this table, they've already put it in order from least to greatest for us. So that would be -3, -2, -1, 0, 1, Let me fix that one because that wasn't very good here. So 0, 1, and 2, and my set notation there. So then we're going to do our range, and again from least to greatest. So I've got 5, negative 2, then negative 1, and then, oh, look, I have 2 5s. So in my set, I only have to write each number. If a number, especially in the y, well, even in the x, if you had to do that, you only write it one time. So notice I have 2 5s here. I'm going to highlight it. I have a 5 here, and I have a 5 here. I only need to write it in my range when I'm writing it down one time. So this is 5, and then 6, and then 7. Okay, there we go. So there's my domain and my range. Awesome sauce. Good job. Okay, so we're going to go ahead and go to the next problem here. And my next problem says, determine if the relation given by the mapping diagram is a function. So we're still doing the same thing. I still want to determine if it's a function. And then I want to find my domain and my range. Okay, there we go. So let's see. So A only has 1 arrow, and B only has 1 arrow, and C has 2 arrows. That means this is my input, or my x's, and this is my y's. This means this x has 2 y's, which means not a function. Okay, so if I have an x that has more than 1 y, it's not a function. Good job. So we're going to go ahead and go on to the next problem. I think I can get all that on one page here. Okay, determine the relation given by the set of ordered pairs. So we're doing exactly the same thing. I want to determine if it's a function, and then find the domain and range. So on this one, I think I'm going to do, which one am I going to do? I think I'm going to do this one. Okay, so we're going to look again at the x's. So first I want to look at my x's. That's always what I want to do to determine if it's a relation. So I've got a 10, a 1, a 9, a 1. Oh, I have 2 1s. Now, are my y's different? Well, I've got 9 and I've got negative 3. So they are different. So this is not a function. Awesome. Okay, good job. So next we have a graph, and I want to determine, again, same thing. I'm going to determine if the graph represents a function, and if it is, find the domain and the range. So if I have a graph, how do I find out if it's a function or not? Does anyone remember? There's a test we can do. Yes, it's the vertical line test, which means if I draw a vertical line, if I draw a vertical line here, and I'm going to try and do this, and then it won't let me. I was hoping the line would stay and the paper would move, but it didn't work. If I could move that line, slide it back and forth, does it intersect this graph in only one place, or does it intersect at more than one place? Well, in this case, it only intersects ever in one place. So this is a function. And if you're not sure and you don't know, you can take a pencil or a ruler or whatever and slide it across that graph and see if it ever intersects in more than one spot. And this one doesn't, so I need to find my domain and my range. So the nice thing about this, the nice thing about this is it's got arrows on the end, and arrows on the end means it's going to keep growing in those same directions. So not only is it going to keep going, this one's going to keep getting wider and wider and higher, and this one's going to keep getting wider and wider and lower. So that means my domain, my x's are going to keep going forever, and my y's are going to keep going forever. So my domain is from negative infinity to positive infinity. Remember, I always do domain and range from least to greatest. And infinity is never included in anything, so that's why I'm using a parenthesis. And then my range is going from also negative infinity to positive infinity. Good job. Okay, next we have this shape, and if I drop a vertical line here, look, I have one here, one here, one here. It intersects in how many places? 3. And how many can it intersect in? 1, correct. So that means this is not a function. Great, awesome. So we're gonna do the other one in a little while, and we're gonna go ahead and move on to the second page here. Here we go. Okay, you guys are doing great. We're doing great. So number 2 here says write y equals x squared plus 3x minus 1 using function notation. Okay, so function notation, remember, was f of x. So I'm going to replace, this is hard, I'm going to replace my y with f of x or g of x or h of x, whichever one you want to use, okay? It's all the same thing. But the most common one is f of x. So f of x equals x squared plus 3x minus 1. And that's it. That's how I write an equation using function notation. Done. Okay. Now we're moving on to evaluating the function. And we have a few problems to do here. Okay. So how do I evaluate the function? Well, this says f of negative 2, which means I'm going to take that negative 2 and in my function that they've given me, which is 5x minus 9, because it says right here, 5x minus, f of x equals 5x minus 9. And they want me to find this whole list of things. So in this function, wherever there's an x, I'm going to put negative 2. Okay, or 0, or a, or 2a, whatever's in that parenthesis, f of whatever, that's what's going in what my x is. That whatever is going where the x is. So that means f of negative 2 is going to equal 5 times negative 2 minus 9. So now I'm just going to simplify this. So 5 times negative 2 is negative 10 minus 9 equals negative 19. Nice job, guys. So we're going to do one more of these, and then we'll talk about the rest later. I think we're going to do this one here. So we're doing this one and this one. So now this says p plus 3 inside my parenthesis, f of p plus 3. So wherever there's an x in my function, which is 5x minus 9, I'm going to put p plus 3. So I have 5 times p plus 3 minus 9. Now I need to simplify this, so I'm going to distribute, which is 5p plus 15 minus 9. And so if I combine my like terms, I've got 5p plus 6. Done. And there's my answer. Okay, so basically I'm taking something out and I'm substituting it back in, like in basketball or football or any sport basically that you play where you take something out and you put something of equal value back in. It just might look differently. Okay, so we're going to go ahead and go to the next section. And this is the last section that we're going to do in the video. The last section on these notes we're going to do in class synchronously. Boy, I can't say that word very well. But we're going to do it together. So now I'm given the function g of x equals 3 times the absolute value of x plus 5 minus 1. Okay? And I think I'm going to do this one this time. Okay? So here we go. So wherever there's an x, I'm going to put negative 4, right? So I've got 3 times the absolute value of negative 4 plus 5 minus 1. So absolute value bars kind of act like a parenthesis, so I want to do what's in there first. So I've got 3 times the absolute value of 1 minus 1. And what's the absolute value of 1? 1. Good. So 3 times 1 minus 1 is 3 minus 1, which is 2. Perfect. Good job, you guys. So that is all we're going to do here today on the video. The rest we'll talk about in class when I see you. So have a great day, and I will talk to you soon. Bye.